Zeno's paradoxes explained simply. Dive into the ancient world of Greek philosophy, and you'll quickly run into a mind-bending, time-tested enigma: Zeno's paradoxes. These aren't just quirky historical footnotes, they are ingenious, frustrating, and brilliant intellectual traps set by the pre-Socratic philosopher Zeno of Elea around the 5th century BCE. Zeno's goal wasn't to mess with your head for fun, but to defend the radical monist views of his teacher, Parmenides, who believed that change and motion were mere illusions. Zeno used these paradoxes to show that assuming the reality of motion and plurality, many things, leads to logical absurdities. We're going to break down the most famous of these paradoxes, moving past the usual dry explanations and showing you why they still spark intense debate in math, physics, and philosophy today. A. The paradox of the dichotomy, the racetrack. This is perhaps the most straightforward and most unsettling of Zeno's arguments against motion. Imagine you want to walk from point A to point B. The inescapable trap. Zeno argues that to reach point B, you must first cover half the distance. Once you've done that, to continue to point B, you must cover half of the remaining distance, and then half of that remaining distance, and so on ad infinitum. Step 1. Cover 1/2 of the total distance. Step 2. Cover 1/2 of the remaining half, i.e. 1/4. Step 3. Cover 1/2 of the remaining 1/4, i.e. 1/8. The argument is, since you must always complete an infinite sequence of non-zero length segments, half of what's left, before you can reach the end, you can never actually start. The journey is logically impossible before it even begins. Why it's a paradox? Our everyday experience tells us we walk across rooms all the time. But Zeno's logic seems flawless. There is always a smaller segment of space left to cross. He is essentially suggesting that to complete any finite distance, you must complete an infinite number of tasks, which he deemed impossible. A. Achilles and the tortoise. This is the most famous and playful of the bunch, pitting the great, speedy hero, Achilles, against a slow-moving tortoise. The race Achilles can't win. Assume the tortoise is given a head start. Zeno argues that Achilles can never overtake the tortoise. 1. To catch the tortoise, Achilles must first reach the point where the tortoise started. 2. By the time Achilles reaches that starting point, the tortoise will have moved a new, smaller distance forward. 3. Achilles must then cover that new distance, but in that time, the tortoise moves forward again, albeit an even smaller distance. This leads to the same infinite sequence problem as the dichotomy. Achilles must always cover the distance to the tortoise's previous position, but in the time it takes him to do so, the tortoise creates a new gap. Since there is always a gap, no matter how tiny, Achilles can never catch up. F. The arrow paradox, the still flying arrow. This paradox is less about distance and more about time and the instant. It's the most challenging for modern physics because it forces us to question the nature of time itself. The illusion of motion. Consider an arrow in flight. Zeno argues that at any single instantaneous moment in time, the arrow is not moving. If the arrow is moving in a particular instant, it would have to be covering some distance during that instant. but an instant is a durationless slice of time, t equals 0. If the instant has no duration, the arrow can't move, as motion requires a change in position over time. Therefore, at every instant of its flight, the arrow is motionless. If it is motionless at every instant, then its flight, which is made up of these instants, must be an illusion of stillness. This paradox forces us to confront how motion, which is continuous, can be built up from discrete, static moments. Light, the modern friendly resolution, calculus. For millennia, Zeno's paradoxes were intellectual kryptonite. What finally provided a satisfying, formal resolution wasn't ancient wisdom, but 19th century mathematics, specifically the rigorous development of calculus and the concept of infinite series. Why they still matter today. Even though math has resolved the mechanics, Zeno's work remains profoundly important. It, 1. Challenged the foundations of logic. It forced thinkers to be more rigorous about the continuity of space and time. 2. Paved the way for calculus. It highlighted the exact logical issues that the concepts of limits and infinity needed to resolve. 3. Informs physics. The arrow paradox, in particular, touches upon deep questions about the relationship between time, motion, and quantum mechanics, where physicists still grapple with whether reality is fundamentally continuous or discrete. Ultimately, Zeno's paradoxes are a magnificent reminder that our intuition about how the world works can be easily fooled by rigorous logic. They stand as a timeless monument to the power of philosophical thought to challenge and redefine our understanding of reality. You've made it to the finish line of this mind-bending race. If Zeno's brilliant traps have sparked a new thought about space, time, or infinity, smash that like button. Did you find the dichotomy or the arrow paradox more confusing? Let me know in the comments below. Let's keep this philosophical discussion moving. And to join us for more deep dives into the weird and wonderful corners of history and science, be sure to subscribe and ring the bell.